Alright guys, so first one, what's the answer?
M.
M. I love it. It's got to be and both, so M is the only one that's in both. So the answer is What about number 2?
Just right here.
Yeah, write everything. So
Just blank.
car, whoa, by. Alright, got by. Plane, horse. Alright. Cool. Okay, cool. And the last dude?
Empty bracket.
Empty set. So you can either write that as that or that, empty brackets. And see here, no solution really doesn't make any sense on this one. We're not solving an equation, so the answer's got to be some kind of a set. And it's an empty set, because that's all the answers. None. And you guys see why? Is that cool? There's no number that's in this and that. Okay, good. Not too bad, right? It's not too bad. Let that be easy. Alright, so here's the heart of today. 10.2 and 10.3. And then, well, yeah. So 10.2 is where we do, like I said earlier, I promised we'd do absolute value equations. We're also going to do absolute value inequalities. And I'm going to tell you how that relates to restraining orders. Somehow that's going to come up today. So I apologize in advance if you are living through that. I still use that as an analogy. So everybody got what they want from this here? Mm-hmm. Okay. So let me ask you two easy questions and then a deceptively hard question. What's the absolute value of 4?
4.
That's great. What's the absolute value of negative 4? 4. And of course we all understand why that is. What physical property is absolute value based on? What physical thing is absolute value based on?
Distance.
Distance. So I don't care if I'm looking at you or I got my back to you, you're still 4 feet away from me. You're not going to say you're negative 4 feet. You're in me. You're like that little Martian dude. Quaid. No? Yes. Total recall. So it's based on distance. So both of these, how far away from 0 is 4? It's 4 away. How far away from 0 is negative 4? It's 4 away. 4 units away. I like it. So what about this? No, you're wrong. You're wrong. You're wrong. Now you're just like, x squared. Tree. Shit. So look at this. What could x be? Couldn't x be 4? And then what does the absolute value do to it if it is 4? Did the absolute value do anything to it? Does it do anything to it? No, it's still 4. But what could x be? Negative 4. And then what does the absolute value do? What did the absolute value actually do? Mathematically, what did it do? What can I do to negative 4 to make it become 4? Good. So if this is negative, so let's see, how do I write this answer? I write this answer like this. If x is less than 0, if x is negative, x is negative, I must change its sign, must I not? And this is where students balk. You're like, that you know. But x is negative, like x is negative 7. So what's negative 7? 7. See, that's what it's doing. So, but what if x is 0 or bigger? What's the absolute value do? What does it do if you're already positive? What does it do to you? Nothing. All right, let me let that sink in for a minute.
So that would be the answer.
That is the answer, which is unsatisfactory, right? That's not satisfying in any way, but that's the best we could do, because the absolute value, to really let you in on something interesting, I personally don't like the idea of the absolute value, because it's an evil thing. It looks like it's one function, but it isn't. It's 2 functions. And that's why it looks the way it does. What does x look like? Isn't it just going to be like this, right? From 0 up. But the minute I'm below 0, I look like I got a negative slope. That's why the absolute value looks the way it does. These are 2 separate functions. I don't want to be in this plane. If the plane goes, you're dead. You can't handle that kind of turn, right? You with me? So it can't be a continuous function. It's actually two separate functions. All right, maybe. I don't know if you really understand. No, so what's up? Absolute value does not do a single thing. It does two different things based on what's in it. So if I don't know what's in it, I don't know what it's going to do. I have to say, well, it's going to be this or that based on what x is. I don't know what x is, right? Does that make sense? That's why I have to write it so weird, because the absolute value is a little evil. It hides the fact that it does two different things.
Is it just with one bracket or?
Say again, sorry?
Is it just with one bracket or?
Oh yeah, this is a special kind of thing. It's called a piecewise function. So it's a function that's got two pieces to it. So we call it a piecewise function. So it's not really a set of things. This is just a organizational symbol. There we go. All right, maybe. So how does this affect us at all? I don't know. Well, let's see. So this affects us in how this acts in equations. So for example, if I said, let's start really nice and easy, like we always do in math. You think that you're okay, and then we'll hit you with the hard stuff in a minute. This should be relatively easy. Exactly. And the way you think about it is, the inside, whatever this number is, to make it 3, it's got to either be 3 or negative 3, right? How we doing? So do you notice how there's always two cases involved with absolute values? Cool. That's important. All right.
You would write that the same, right? The 3 and the negative 3, just like that one with the s.
Oh, here?
Yeah, you would write it the same with the 3 and the negative 3.
Oh,
Bracket and then 3 and then negative 3 on the bottom.
you could use brackets like this, sure. Right, as a no, Jeff, make it 3. There it is. Or you could write x equals plus or minus 3, like somebody said. I mean, yeah, you don't have to write it like this. What's up? Oh, in my brain, I've got 3 and a bracket kind of melding together into one beam. At the end of the fly. So what happens? Let me do this one in two different ways. I'm going to do this one in two different ways. The first way I'm going to do it is a way that we're not going to use very much. So why am I going to show it to you? Because it explains a little bit of what's going on. The second way we do it is the way that we're going to do it most often, because I can only do this the first way because it's such a simple equation. All right, so here we go. What am I talking about? So the first way is, what this says is the distance between the answer and 1. And why do I know this is talking about distance? Because this is a subtraction, right? So the distance between the answer and 1 is 7. So the answers are 1 away from 7. So what should the answers be?
7.
What's 1 up from 7?
8.
And what's 1 down from 7? Yeah. Right? How are we doing so far? No, now listen to me. I'm doing this all backwards. That's what my brain is yelling at me. All right, let me try this again. So I said it right first, and then I did wrong things. So the distance between the answer and 1, I kind of switched these together. The distance between the answers and 1 is 7. So it's got to be 7 away from 1. So 1's in the middle. So why does this one work the same way? What am I subtracting from x in here? Am I subtracting anything from x? No, so I'm subtracting nothing. I'm subtracting 0. So this really, I can look at this the same way. The distance from x and 0 has got to be 3. That's why the answers were 3 and negative 3. So the distance between 1 and x has got to be 7. So what's 7 up from 1? 8. And what's 7 down from 1? Negative 6. All right, that's better. So that's the way that we're not going to be able to do it all the time, because the minute I start putting more stuff in there, then that's not that easy to see. So here's the way we can do it most often. This is the algebraic way to do this. I do it the exact same way we just did this. What could this inside number be? It either has to be what or what? X minus 1 So for the absolute value to come out to be 7, what could I put in here? No, absolute value of 8 is 8. You're thinking, you're solving, what can the inside be? So the answer comes out to be 7. It could either be 7, or the inside could be negative 7. All right, let me stop there for a second. Those are the two cases. So again, if I ask you, if I just gave you this, put something in here so that that's true. Put something in there so that that's true. What could you put in there? So you could replace x minus 1 with 7. So x minus 1 could equal 7. Or what else could you put in there? Negative 7. So you could replace x minus 1 with negative 7. And it would still work. Alright, so what are the two cases then? Either the inside is this, or the inside is the opposite of this. Those are the two cases. And then you solve it, and look what we get. We get 8, or add 1, negative 6. Cool. So that is 7 away from 1, both up and down. So this said the distance was 7 from 1 to the number. 7 up, 7 down. So when we did it algebraically, we got the exact same answer.
There's always two possible answers.
Exactly. And the two possible answers relate to the two possible options for what you put in there. So let's do another one where it's a little bit more complicated. So the mistake people make for some reason, and I try to stress this, like you just said, there's always two cases with absolute values. For some reason people just kind of ignore the absolute value and just kind of solve it. No, you can't do that. Why couldn't I do this? Why couldn't I just go, alright, there you go?
Because you don't have to have two values. Because it's either 11 or negative 11.
But more fundamentally, why can I not do that? Because where is the 4? It's stuck inside of a absolute value. I can't break in there and take him out. I can't. Exactly, that's another thing. It would lead to one answer, right? But most fundamentally, I just can't break into the absolute value and take somebody out of there. So this step, the step that you guys said, there's got to be two cases. Do you see how the absolute value is not there anymore for the two cases?
Yeah.
Because the two cases talk about what's inside. Then I'm allowed to move stuff around. So what's one case going to be?
4 minus 5x equals 11.
Yeah, if I replace this with 11, absolute value of 11 is 11. That would work. Or if I replace this with negative 11. If I put a negative 11 inside instead of that, absolute value of negative 11 is 11. Do you guys see where those two cases come from?
Yeah.
Okay.
And now you can just solve
And now I solve each one. Kick ass. I like it. And why does it, real quick little word, remember that absolute value, this is not going to be perfect, but it's going to look something like that. You with me? And here's 11. How many places is the output 11? 2 places. There you go, right? That's why there's 2 answers, because there's 2 places where it could become 11 as an output. So what do you get here? Subtract 4. Divide by negative 5. I get x is negative 7/5. Is that cool? Over there, subtract 4. Divide by negative 5. And you can check like anything, right? So if you plug a 3 back in, 4 minus 15 is negative 11. The absolute value of that is 11. Yay! Let me let that sink in. But see, these make sense because if this did equal negative 11, then this would be true, right? So solving this is equivalent to solving this. So I take a problem that's really kind of hard to do and I break it into 2 easy to do problems. Bam. I like it. All right. So, what if it looked like this? Don't worry, this is kind of like its ultimate form here. Don't worry, it's not like. And now, what if it gets even worse? Let me not do several things. I'll do one thing at you at once. How is that fundamentally different from this problem? There's only one real difference.
Seven out of the bracket.
You can't.
Yeah, there's an extra term in there, right?
So you gotta like subtract the 7.
Beautiful. You have to isolate your absolute value first. So this property, this two outcome, this two case thing I'm doing, because I don't know words apparently, will only work when I have absolute value of something equals a number. So that plus 7 is kind of like in my way. So the big mistake is people will just do blah 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 negative 11 and blah 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 11. That's never going to work. It's no good. Another mistake, before I forget, is I'll have people just do this. Don't write that down. It's a mistake. Do you see what that person's thinking?
Yeah.
Why is that person wrong?
Because you're only going to get one answer.
No,
I
because you're
agree with you. That's how you know it can't be right.
You got two answers.
Because you can't bring
But why is that wrong to do?
7 is out of the set.
There's no.
You're not plugging in 11 to the absolute value.
What did this person do? So they thought absolute value negative 2 is 2. So they're like, Chad, what's wrong? That's what you said. You're saying that's not right? I'm saying, no, that's not my question. I didn't ask what the absolute value negative 2 is, right? So if I said, what's the absolute value of 7 minus 8? What's wrong with me saying the answer is 7 plus 8? That's no good, right? That's not fair. Why does 7 escape having anything done to it? So it's the absolute value of something I don't know yet. So I can't just make any minus I see into a plus. I'd actually have to figure out what this number is, and then I could do it. Can I figure out what number that is? No. And that's why the two-case way is a way around that. Okay, maybe. You can't change a part of a number. All right. So now the first thing, like you said, is to do what? Subtract 7. I'll make it look like 13. And now we can do
Come up
what we were
with
doing
2
before.
and negative 2/3.
So we get 3x minus 2 equals 4. 4. 3x minus 2 equals
Negative 4.
negative 4. Kick ass. So you add 2, divide by 3. 2 is cool.
2, yep. And then
Add 2, divide by 3. Negative 2/3. I like it. 3 is like, come on, man. It's not too bad, right? What's most important is that you understand why that happens. It's nice if you memorize it, that's great. But does it make sense why that has to happen? That's what's important. So here's, this is not really even a harder thing, but it's just something to watch out for. What could happen with any equation? I could have an answer, I can have several answers, or I could have no solution, right? So sure enough, it's easy to make a problem that would have no solution for absolute values. Let me see you guys catch on here.
It can be negative 6.
Exactly, because the first thing you have to do here is what? Subtract the 5. You get that extra term, you want to get it the hell out of the way. So then you have the absolute value equals a number. But when you subtract 5, you get the absolute value equals. Can that happen? Now, if you did the work, if you made 2 cases, you actually get 2 answers. And they're both, of course, wrong. And the thing to get over is it's not math's fault. Is this equation valid? No. So the sooner you can tell that an equation is not valid, that it's bogus, that's a bogus equation, you can right there stop and just say no solution. Right? So right here, you want to stop and say no solution. It's a little bit evil that if you did keep going and you made 7 minus 4x equals negative 2, 7 minus 4x equals 2, you get 2 answers, and if you don't check them, you will never see that they don't work.
So when you find that an absolute value equals a negative number,
Stop, write no solution, and you're done. Because that can't happen. We know that. It's a fundamental idea of absolute value.
yeah.
Cool. Okay. Okay. So let's talk about what happens with absolute values and inequalities. Now let's start with my favorite example, the restraining order. So let's do like we did earlier. Let's start with the most basic thing we can do, just an absolute value of x by itself, less than or equal to 4, let's say. So what does this really say? And remember, this is minus 0 here, right? So it's how far away from 0 it is. So it's got to, so from 0, it's got, the distance has to be what?
Greater,
Less than or equal to 4. So it can't go above how much? 4, and it can't go below how much? Does that make sense? In both directions, it can't be more than 4 away. So this is like, stay close to me. This is not my restraining order yet. The greater than is restraining order. This is the, we're about to go into a scary haunted house. Let's stick together. When you split up, you die. We've seen enough movies, right? Stick together, stay close to me. So it says, let your distance be less than 4 away from me. Stay close to me. You with me? Now to really, really draw this out, what would this look like? It's not just this. It's everything in between, right? Because the distance has to be at most 4. So it would be this. So here is let me show you the long way to write out the 2 cases. And then I'll show you the shortcut way that only works for less than. So the long way to do this, the 2 cases would be x is less than or equal to 4. Here's the little evil part. And, now watch this. What happens to an inequality when I do like negative stuff to it?
James.
Yes, so x is less than or equal to 4, and x is greater than or equal to negative 4. Now, doesn't that match up with the picture?
Yeah.
Greater than or equal to negative 4 and less than 4, that's where they overlap. That would be the answer. I like it. So let's stay on this less than for a couple times here. See how it works with other situations. So what if I add absolute value of, what you got, Jen? 2x plus 3 is less than, you can do it, 5. Oh, I forgot. Right. The shortcut way, what's a better way to write this? We can see it from the picture. Where's my answers? They are between what? My answers are between negative 4 and 4. That to me is the preferred way to write that. Because that's a sandwich. Less than is always going to be a sandwich. Do you know what a sandwich is? It's a tasty sandwich. You just say it's a sandwich. Right? So it's got the bread and it's got your jelly or whatever you like in the middle. So less than, I want you to stay close to me, it's going to be like this. It's going to be a set like this. So I should be able to write it as one single line. It's one single set. Greater than is going to be stay away from me. That's why I call it a restraining order. Stay away from me. It's going to be 2 separate sets. Oh boy. So how can I rewrite this then? Here, watch this cool stuff. 2x plus 3 can go up to 5 and down to negative 5. Bam! So when it's less than, you can always write it very quickly in one line. Bam. If it's greater than, no, you cannot do that. Now, hopefully you've had some experience with triple-sided inequalities, right? It's got an inside, a left side, and a right side. So if you want to subtract 3, you've got to do it to all sides. Not just both sides, all sides. So then you get negative 8. And then, of course, I can divide by 2. So I get negative 4, less than x, less than 1. And then how you graph that? What goes on both of those? Yes, ma'am?
Don't we change the sign because we divided by negative?
We didn't divide by negative anywhere.
No?
What did I divide by?
By 2.
By 2. So I'm really glad you said that. Just because there's a negative in there somewhere doesn't mean I switched the signs.
Unless it's we're dividing
If
by
we divide or multiply by negative. Yeah. So I'm going to do something with that in just a second. So what symbols go on here? Parentheses. Good. Because they don't want to include it. So then what would the interval notation look like? It would look like that. It's almost too easy. Absolute value negative, parentheses negative 4, 1, parentheses. So you better believe that, well, in the homework, they kind of sometimes ask you to graph it. They sometimes ask you the interval notation. If I give you one of these problems, you got to do both always. Graph it and interval notation it. Okay. Maybe. So what about, before I get too far. Do you guys know why the sign's got to flip in an inequality when you divide or multiply by negative?
Because all of a sudden it becomes negative. So you have to, if it's like greater than when you're dividing by negative.
But see, why? Why would it have to switch? So, what are variables? They're just numbers, right? So let's see what happens with numbers. Which one of these is bigger? 2. Good. All right, thank you. So if I divide by -1, what does that become? What does that become? Which one's bigger now? What happened to the sign? All right, so that's why does the sign flip? Because it has to.
The value changes.
I love it. So multiplying or dividing by negative is what's called a non-order preserving operation. Holy shit. If it's on this side of the 0, it's now going to be on the other side of the 0. Does that make sense? So 2 was over here. Here's 0. When I divide it by -1, now it's over there. So whatever was bigger is now going to be smaller. So it's sort of like what you're trying to say. The inequality's got to flip to account for that. How we doing? I don't know if anybody ever had that explained to you. So most of the time you just say, you do it, because you do it. That's why we do it. All right. So what about greater than or equal to? So let's start with a simple example again. So the distance between x and 0 has to be more than 7. So I cannot get closer to 0 than 7. So 1 won't work and so forth, right? So the closest I can get is 7. And where can I go from 7? Up. So the closest I can get from this side is to 7. Now you see why I call this the restraining order, right? Now 7 feet is not that big of a restraining order. I can still throw stuff at you. But this person, here's the person, and they can only get right there. Or else, some bad things can happen. And down here, how close can I get? -7. And I can go down from there. So it's 2 separate sets. So officially, this would be x greater than 7 or x less than -7. See how that's there, that's there. Maybe. Now watch, I'm about to make a mistake, so don't write this down. But if you took this and tried to do the same thing we did down there, if you try to write -7 bigger than x bigger than 7, do you see what I'm trying to do here? Why is that completely crazy?
Because -7 is not greater than x. Is that right?
You almost had it. So even more blatantly crazy.
We didn't change.
Is -7 bigger than 7?
No.
No, so that's bullshit, right? Good. So greater than you cannot write in a single statement. Less than you can.
Oh, okay.
Now, if you want to, you could do these problems. You can always do them like this if you want to. You don't have to do them this way if you don't want to. But I'm hoping you see how this way is just a little bit more efficient. All right, maybe. Okay, so here, you guys try this one. Maybe a little bit evil, but you guys are used to that by now. Sure. So solve it, graph it, interval notation it, all that stuff. how many options do I have for rewriting this? One. Right? I cannot write this in the sandwich form because it's greater than it, right? So the two cases are 3 minus 2x greater than equal to 11, or 3 minus 2x
Equal to negative 11.
less than or equal to negative 11.
Oh,
Like,
okay. Wait, why is it switched again?
because, real quick word on that. Okay. There's a whole other kind of way to teach this kind of thing that I personally don't like, but I'll show you a little bit of it right here because it kind of makes more sense out of that. Remember that absolute value of x was x or negative x, right? Blah, blah, blah.
Yeah.
Is that cool? So if I have the absolute value of 3 minus 2x, I could say that that's either itself or it's the negative of it.
Oh, okay.
Let me stop there for a second. Is that cool? It's exactly what this says. It's either itself or it's the negative of it. But if I divide both of these sides by negative 1, what has to happen? Less than or equal to, it's got to flip, negative 1.
Gotcha.
But I just like the idea that this says that 3 minus 2x can get, how close can it get to me on that side? 11. And how close can it get to me on that side? Negative 11. So that to me just makes more physical sense. You can get close at 11, and then from down there, you can get to negative 11. That's how close you can get to 3 minus 2x.
But you don't have to worry about the. Sorry, go ahead.
So you start to solve for x, though, right?
Totally, I'm not done yet.
Same thing.
Yeah, this is explaining why I can write it like this.
But you don't have to worry about the math changing. You just have to worry about the sign being in the right direction, like that way, right?
Exactly, I just have to point it
The
there.
right way. Okay.
Yeah, so I kind of, this is a whole other way you can teach a lot of this stuff that we learned today. I just don't like it as much. So then what can I do from here? Subtract 3. Good. Change the sides. Gas. So that was a little bit of evilness I put in there. Or, look at that. My mutant 3s. Negative 2, negative 2. Switch the signs.
Oh, so you're divided by negative.
Divided by negative. Oh, I was evil. Good. All right. Why do I say good? Because it's better to make mistakes now than on something that's actually graded. And then how do I graph this? Less than or equal to negative 4. What goes on the negative 4? Who? Bracket, right? Because I'm allowed to equal it. Greater than or equal to 7, so bracket again, and out from there. Now it might make a little more sense why we write the answer the way we do. How do I write this in interval notation?
Negative.
Like infinity up to,
-4.
or, no, Jeff.
Wait, wouldn't it be bracket?
Yeah, it would be. Bracket 7 to infinity. Kick ass. Because it could be that set or this other set. Two separate sets. Cool. So that's why I call that restraining order. And this is the sandwich. Right, when it's less than. Okay. How are we doing? I have some concerned looks, but they're at least interested, concerned looks. All right.
I got a question.
Yeah.
So on the or, so when you do 3 minus 2x, you just naturally just flip the sign?
Exactly. And this is really why. Because the absolute value leave it the same or the negative of it. So if I divided the negative 1 to the other side, it would switch. Cool. Okay. Now obviously, hopefully, if I had a problem like this, oh, there we go. Interesting. What do you have to do first here?
Subtract 5 and it ends up being no switch.
Now you gotta be careful. We are dealing with inequalities, which always means there's more options. So I'm not saying that this equals a negative number. I'm saying that the absolute value of something is bigger than or equal to a negative number. Well, what's always true about an absolute value? Positive. So when will this not be true? When will this not be bigger than negative 3? When will it not be bigger than negative 3? Well, you guys can do it. Absolute value. Absolute value. What's the smallest it could be? 0. So the smallest this could be is itself already bigger than that.
That's a negative number. Yeah.
So think about it. What's the answer then? Are there any x's that would make this not true?
All real numbers.
All real numbers. Cool, thank you. Because when is an absolute value bigger than a negative number? All the time. So all real numbers, or you can do your r with another spine on it, right? Or you can do your negative infinity up to infinity. All those different ways to say the same thing. Maybe. That's a special case, right? Yes?
Why is this one all reals and the other one equal negative and no solution?
I love it. So, can an absolute value ever equal a negative number?
No.
Never. But that's not what this says. It says an absolute value has to equal or be greater than a negative number. And it's always true that it's bigger than. It's always bigger than a negative number. Right? Is that cool? No, it sounds a little freaky, but remember, inequalities always gives me more options. Right? If you said you have to be exactly 12 years old to eat on the kids' menu at Denny's, they're not going to sell many kids' menu items, right? I'm exactly 12 right now. You're a second older. Sorry, Candy. You with me? But they say you can eat 12 and below, right? You guys kind of, I don't even know if they do that anymore. I haven't been to Denny's in so long. All right. No, you didn't like that example? I'm sorry. Right. You have to be exactly this height to ride the roller coaster, right? The day that you get higher, you're like, oh man, that sucks, man. I like that ride. You with me? So that's why inequalities have more options for the equation to work. In this case, it's everything, because it's always bigger than negative 3. So any real number is going to make that true. So if this would have been less than negative 3, that would have been no solutions. No way in hell the absolute value is going to be less than a negative number.
Because absolute value is always positive.
Beautiful. I love it. Kick ass. Kick in the ass in. All right. Okay. Don't get me wrong. I totally understand the absolute values are weird. And you see that right when I'm trying to talk about absolute value of x. That seems like it's going to be easy, but that's weird. Yeah.
Okay, so you said if it's less than or equal to, there is a solution, so you can solve for it. The only time it would be all real numbers is if it's greater than or equal to and the answer is negative.
Okay, all right. So I don't try to memorize too many situations. Just deal with where you're at. So if I had this, just what does that say? It says the absolute value of some number is less than negative 1. No solution. I like it. But if I turn that around, it's always got to be greater than a negative number. So that's why that would be all real numbers. Kick ass. Okay, maybe. The real evil thing is this. You really want to get into evil stuff. Can x minus 7 absolute value be less than 0?
0.
It can't be less than 0, but could it be equal to 0? Yes. So what's the answer?
No set?
7.
Oh.
It can't be less than 0, right? But it can totally be equal to 0. I told you going in that was evil, didn't I?
Yeah.
Didn't I? Very often I would give this as a bonus question on the test, right? Now I probably won't have to make it a little bit more ugly.
It's going to be x minus.
That's right. 8. That will throw them off. Thank you. Well, now it can't be that. Now it can be 9. Oh, shit, I gotta stop saying it. All right. So I think a couple times in the homework they throw something related to this at you. So just watch out for those. Yeah, cool. That's it for 10-2. Oh, one last thing to attend to here. What about this? This is where things get weird. Dude. Seriously, dude? Why? So, I often get people, and I kind of like this in one respect. Somebody thinks that there's going to be 4 cases now. So if you're thinking there's going to be 4 cases, you're not right, but I like the idea. It's an interesting idea. Like there's 2 absolute values there. But think about it. Either these 2 are already equal. If they're both equal, if they're both 8, isn't that a true statement?
Mm-hmm.
Or these 2 numbers are opposites of each other. That's only 2 cases, right?
Yeah.
So if they're both negative, that's the same thing as saying they're both equal. Right? Or if one's positive and the other one's negative, that one's positive and the other one's negative, that's why people do this. 4 cases? No, they both say the same thing. They both said that one is the negative of the other. So here's how you write the cases. Here we go. You ready?
Mm-hmm.
You say that one case is always easy. Case 1 is always just take the damn absolute values out. If they already are equal, then obviously their absolute values are going to be equal. Does that make sense? So case 1 is always easy. Just take the absolute value away. Cool. Or this equals the opposite of this. Yes, sir.
Now, what if there was like just exactly how the equation is?
Oh, no, don't do it. Go ahead.
-8.
All right, I'm not going to do that to you because that gets really difficult to do by hand. I don't know if you can understand why. Because so what he's saying is, what if there's only a -8 there? Don't write that. You always want to get the absolute value by itself before you write cases, right? Yeah. So then you'll add the 8. Subtract the 8. Add the 8. Add 4. Go in the middle. Ooh, that's ugly. I like that you thought of it, though. Maybe that's a good bonus question. So in the homework, you're not going to see that because that gets very strange. Think about it. You can make a bonus like that. So is everybody decent with this? I mean, this is actually exactly what we were doing before. It equals that, or it equals the negative of that. Exactly the same thing. So now you solve what happens here. 2 equals 2 equals 4. Subtract 4. Negative 2 equals 2m. So m is -1. That is an answer. No matter what the other guy says, that is an answer. What's the other guy do, though? The other guy gets interesting. Is that cool? And what happens on the very next step?
0 equals 2.
Oh, well, okay. So if you add m, the 2 goes -4, you can add, yeah, I like it. So no solution on that part. So this part does not contribute anything to the answer. But don't circle that. That just didn't add anything. So the answer is just only that one thing.
Can you answer now why we can't do the whole +8 thing on this? I mean, like what happens if we did do that, if that came about?
It's a little too much to get into right now.
Okay.
Yeah.
I'll have to let it go.
On the day of the review, if there's enough time left at the end that nobody else has any questions, we can go into it.
But we're at least not going to run into that, though, right?
Only, like I said, only in a bonus part.
Okay.
'Cause you understand, like I showed you, it's like how the process we use currently wouldn't work on it.
Yeah.
Yeah. Okay. And I kind of don't want to give it away either. There's actually a semi-easy way to take care of it. But, all right, I'll let you guys think about it. Okay. So last thing we'll talk about today, thank God, all right, is section 10.3, and then we'll do a little preview of 10.4. Ha, so I keep lying to you. That's too bad. You guys get used to it. I just want to remind you what's happening on Monday. It's the review day, right? So I'm trying to do as much as I can today so that on Monday, I just finish up whatever's left in 10, and then the rest of the time we can devote to reviewing for the test. Do you understand? So I know we're doing quite a bit today. Yes?
Do we get the answer key to the practice test?
On Monday, yeah, cool. So over the weekend, I want to let you do it without a net. And then on Monday, I'll give you the answer key. Just want to give you the answer key. Don't make the mistake of agreeing with me, just looking at it. Right, go. Mm-hmm. Yeah, that's what I would have done. Because people do that, and then that's false confidence. It's so much easier to agree with work that's already been done, right? So either do the practice test, don't look at the key, and then check yourself, or just don't do the practice test. Just do the homework. All right, the practice test is an extra study guide, really. All right, so 10.3 is really kind of review of several things. Remind me, if I wanted to graph this on a number line, so this should be easy after all the stuff we've done. How do I graph that? Yeah, put the 4 brackets so I include it, and I'm going to shade one side or the other. So one side of that dividing point is all the answers, and the other side is all the numbers that don't work. Right? So I'm over-analyzing this because we're going to take this idea and go into 2 dimensions. Right? This is only one dimension left and right. I'm going to add in, of course, the y-axis, and we're going to talk about what happens then. So if I have a line, how do I cut it in half? With a point. So 4 is the dividing line between good and evil. Answers and not answers. Right? So the answers are over here. And why are the answers over there? Because if I try something, is 5 bigger than 4?
Yes.
Yes. So then that must be where all the answers are. Because either it works, everything on this side works, or everything on this side doesn't work. It's completely black and white, completely binary.
Making the statement
0, 1.
It's making the statement true or false.
Beautiful. I love it. So, if I take the step up to this, right, so this is old news. This is section 10.3. Now I'm talking about a plane, not just a line. I'm talking about a plane. And if I have a plane, like the plane of this paper, how do I cut it in half? With scissors. I love it. Yes, totally. And if you cut it with scissors, you're going to make a line, right? Especially if we don't let ourselves curve around, right? And I'm going to cut it. I'm going to make a line through it. So how do I cut a plane with a line? How do I cut a line with a point? So what the hell am I talking about? That's why I can hear it. So what I'm saying is, this was easy because all I have to do is get the variable by itself and I can see what point is dividing it. Here, I got to see what line is dividing it. So if I solve for y has got to be bigger than or equal to this line. So if you graph that line, you're going to shade one side of the line or the other side of the line. That's the whole idea. It's exactly the same idea as this, just a little more complicated because now we're in double the dimensions, right? So how do I graph that line? Yeah, I got my 4y intercept, and from there I go where? Down 1, over 1. Kick gas, down 1, over 1. Okay. And really quick, I'm going to make it a solid line that's much like solid circles that we used to use. If this wasn't there, I'd have to make it a dotted line, because that's sort of like open circles. Right? That's how we do this in 2D. We don't make a bunch of little like bubbles. So this will be solid. And now that's not good enough, right? That's old news, graphing a line. If you don't shade, you're not done.
Why is it greater than that? Shade the right side.
Wow, I have no idea what you just said. So the by the book method is to do a test point. Yeah, you always use 0, 0 just because it's the easiest numbers to plug in. What's the only time you cannot use 0, 0 is if the line goes through 0, 0. Then it's not on one side or the other.
Yeah.
So I always talk about like Jets fans and Giants fans, right? There's not many that live on both sides. In fact, nobody that probably does, right? Or Yankees and Red Sox. That might even be better, right? If you're on the right side, you're with me with the Red Sox. I just got myself in trouble. So a test point, if I plug 0, 0 in, is 0 bigger than 0 plus 4? Is 0 bigger than 4? No. So that point did not work. Therefore, all of these points don't work. So where do I shade? On the other side. That means that whatever that point is has got to work, right? In fact, let's pick a point. 3, 1 is in there, right? 3, 1. The fact that it's in there means what? Yeah, so when I plug 3, let's just do it right here. 3 plus 1 equals 4. So it would actually be on the line, but I can't draw worship. You kind of with me? So any point I pick on this side has to work here. And of course, any point I pick on this side would not work there. That's the idea. It's not too bad, right? No. Okay. So here. What about if I do this to you? You can do it, John. Oh, that's ugly. Let me make that better. Sorry. Make that a 6. So I mean, make it 2 of them. I heard sounds, meaning that people just love this problem. Now, the problem we just did, was this problem difficult? Be honest with me. Was this problem hard? You have to be able to draw a line. If you're not, you probably should leave. So draw a line, and then you do a test point to see which side to shade. That's all there is. So here, I do that whole process twice. Ooh. So if I can do it once, I should be able to do on top of the line another one.
And then you show where they overlap.
Beautiful. And then where the shadings overlap, that area will be the answer. Now, real quick word, because it's always nice to know how this relates to real life. In real life, I could have, for example, something like this could be on an elevator. I want less than 6 people on the elevator, right? So maybe 3 kids and an adult or something. I don't know. Maybe this is a weight restriction. You kind of with me? So this is related to restrictions in real life. So in an elevator, I can have at most this many people, at most this much weight. So if I graph all my restrictions, maybe this would shade down, and then I do another one, and this shades down like that, then I know this is my safe area. So I know if I have a point that's here, I'm not going to do